Good evening, everyone. Welcome to Sustainable Princeton's Sustainable Minds event, Building Sustainably, Sustainable Design and Development Practices as a Means to Fight Climate Change. My name is Christine Symington, and I'm the Executive Director of Sustainable Princeton. Bear with us for just a second. Here we go. I'm going to extend our thanks to Energy for sponsoring our Sustainable Minds event. And also want to give a special thanks to the AIA of Central New Jersey for partnering with us to offer this continuing education opportunity. Credits earned on completion of this course will be reported to AIA CIS for AIA members, and certificates of completion for both AIA members and non-AIA members are available upon request. This course is registered with the AIS CS for continuing professional education, and as such does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material or construction of any method or manner of handling, using, or distributing or dealing in any material or product. And before we get into the meat of our event, just a couple of housekeeping notes. If you have any questions, you can click on the Q&A button in the toolbar and enter your questions, and we will address them during the Q&A session at the end of this webinar. And all of our events, our Sustainable Minds events, and any other webinars are available on our YouTube channel. You can find them on our webinar archives on our webpage. And I want to remind everyone, or let you know for the first time, that the town of Princeton is undergoing an update of its community master plan. This is something that happens every few decades. And I encourage everyone to visit the Engage PrincetonMasterPlan.org website and sign up for notifications so that you can get notified for opportunities to provide your feedback. And also as a reminder, our sessions, the Sustainable Mind series, are so that we can inform our community about the town's climate action plan and update our community on solutions that will help us to achieve our climate action plan. Part of the climate action plan, or actually the objective of the climate action plan, is to reduce our emissions. And as a reminder for folks, this is a snapshot of our inventory. Princeton's greenhouse gas inventory includes emissions from the commercial sector. So that is our commercial buildings, that is the energy used to heat and cool and electrify our commercial buildings, and our homes. So what you see in green and blue is pretty significant contribution to our emissions. In yellow is transportation. And that's another major contributor to our emissions. To give you a historical perspective, this shows you what our emissions have been going back as far as we have recorded data back to 2010. And you can see during the pandemic that our community emissions did take a little dip, but now they were getting back to normal. They're starting to trend back upwards, which is why it's really important for us to make our commercial building sector and residential building sector as efficient as possible. And that's going to be really what tonight's session is about. In the Climate Action Plan, we have a section about energy, and tonight's event will focus on Objective 1, which is reducing emissions in the built environment, and also Objective 3 in our land use and transportation section, which is to promote mixed-use development and pedestrian and transit-oriented location-efficient neighborhoods. So I'm going to launch a quick poll here. Tell us a little bit about yourselves so that our panelists can get to know who we've got in our audience. So take a few moments here. Great. See a lot of folks answering the questions. Great. So let's take a look. All right. To answer the question, I'm here because 20% are here to get AIA continuing education credits. About 31% are sustainable development novices. 39% are pretty knowledgeable about sustainable development, but looking to stay up to date. And about 60% of us are looking to have more productive conversations about housing and development. And 63% of our attendees tonight are from Princeton. 33% work in Princeton, and about 31% are an architect. Great, it was very helpful. Thank you. So it's my pleasure to introduce our two panelists this evening. We have Ken Levinson, who's the Executive Director of the Passive House Network, and Christina McPike, who's the Director of Energy and Sustainability with Wind Companies. I'm going to just jump right into having them enable their cameras. And Christina, you want to tell us a little bit about yourself, and then Ken, if you want to give a short bio for our audience, that would be great.
Yeah, sure. Happy to. Good evening. Thanks everybody for joining. I'm excited to be here. This has been really fun to work with Alana and Christine the last couple of months to prepare for the conversation and presentation tonight. I'm Christina McPike. I'm the Director of Energy and Sustainability at Wind Companies, and I'll describe the company a little bit later in the presentation. Ken, you want to introduce yourself?
Oh, sure. So hello, I'm Ken Levinson. I'm the Executive Director, as noted, of the Passive House Network. And I'm an architect by background and training, practiced for a couple of decades, mostly in New York City, and really sort of got hooked into Passive House at about 12 years ago in thinking about the climate crisis, and started working and promoting the Passive House standards and working towards more sustainability at that time, and have kind of been working in various ways ever since.
Yeah, thank you, Christina and Ken. I can tell you how excited we were to have both of you here, and I want to give a big shout out to Alana Burke, our communications and outreach manager, who worked really hard to pull this together and chase down getting this event to count as continuing education credit. So thanks a lot, Alana, for doing that. So, all right. So you told me when to advance the slides. I'm going to turn off my camera and hand it over to you both.
Sounds great. Thanks, Christine. Let's jump into it. You could probably click a couple slides ahead here. Yeah, so again, Christina McPike, and I think we have our contact information on the last slide here as well. Learning objectives for the presentation, and we're going to be talking about buildings, how to design, develop high performance sustainable buildings, and why we care about doing that and why we want to be doing more of it. So we'll get into the sort of fundamentals of what a high performance energy efficient building is, the role that sustainable development plays in supporting social equity, as well as access to housing and access to affordable housing. We'll get into a case study in Princeton, help talk about the co-benefits of sustainable development and how to sort of make a financial case for these types of projects. And we'll get into the $370 billion Inflation Reduction Act, at least at a high level, some sort of exciting happenings there and key takeaways for how we think that is going to help accelerate high performance development and tackling climate change. Next slide. Before I hand the mic over to Ken, I wanted to give just a brief intro on wind companies. Christine, you mind advancing the slide? There we go. Thank you. The Wind is a 50-year-old family-founded and operated mixed income multifamily housing developer, long-term owner, and property manager. We were founded 51 years ago. It sounded a lot cooler last year when we could say 50. And I've grown to a company of 3,500 employees and a portfolio under management of about 120,000 apartments in 23 states and DC. We own about 13,000 or so apartments in about 90 communities, all in the Mid-Atlantic and Northeast regions. And we have a small but mighty sustainability department, a whole team dedicated to one of our guiding principles, which is the company's commitment to sustainability. So it's not a new trend or a marketing scheme. It's just good business. We own buildings. We are an asset manager. We manage buildings for other owners. And most importantly, we maintain healthy and safe housing for the folks who call our buildings home. And sustainability sort of enhances that at every level, from carbon emissions to utility costs to to comfort and well-being. So really excited to be here tonight, get into the weeds on some of what we're doing at WIN. And before doing so, I'm going to hand it over to Ken to introduce himself and the Passive House Network. And I think he's the thought leader tonight. So he's the brains in the operation.
No, not at all, Christina. It's an honor to be here with you and glad to be with everyone. I was really thrilled to be asked to present with Christina here this evening. Just briefly, the Passive House Network is a national nonprofit. We are really focused on capacity building, on global knowledge sharing, and finding local solutions, connecting to local needs, and really harnessing the talent around the world. We are affiliated with the Passive House Institute and the International Passive House Association. And so it really truly is across the country and around the world a global effort. This is kind of our elevator pitch here. I thought I would test it out, which kind of goes with the theme in terms of discovering more around green building. People who want green buildings often don't have clearly defined realistic targets for what sustainable building really is. So the Passive House Network is really about providing education and community to professionals, and I would also say consumers across the building industry, so that they can make the best design and construction decisions every time. That we're about showing that if we work together, we can build a better world. There's a QR code there. You can download our brochure. And we'll see, a lot of this is about basic building science and its application and just doing it with purpose towards better outcomes. Next slide, please. So we're talking about buildings, and they're super important. You can see in the graphs around Princeton's carbon emissions, going to commercial and residential power usage. Are a big part of our emissions. They're a third of the global emissions, more than a third of the global emissions in places like cities like New York and other cities, Boston. They can be as much as 75% of the emissions or more. At the same time, we're spending 90% or more of our time indoors, a lot of time indoors. And our buildings are, sadly, typically, quite often are failing us. in sustainability, but in basic services, that they're just unreliable in terms of their performance. They can be very expensive to operate and maintain. And too often they are unhealthy. They're making us sicker, actually, whether it's mold and allergies, asthma, and so on. So it's really critical in terms of sustainability, the role that we have in buildings. Next slide, please. And so sustainability, I would say it's kind of like the green ink blot Rorschach test. What does it mean to you? And there's a laundry list, right? And this is just a very partial list, but we can go down it briefly here. Reduce carbon emissions. We have to massively reduce our carbon emissions. We need to stop burning fossil fuels, period. Part of that is going to net zero energy, whether it's in the building, the community, or globally. We need to zero that out. We need healthy environments, both interior environments within the buildings, but also how the buildings are affecting our exterior environments. Providing resilience, that people can shelter in place in storms, that they can be less vulnerable and more secure. Affordability in operation, but also in construction and in maintenance and going forward, that if we are reducing our energy usage, if we're reducing our costs, maintenance and operations, we can insulate and protect people from energy shocks and make operating our buildings much more affordable. And this can speak to issues around environmental and social justice as well. Certainly where folks traditionally been underserved and are living in substandard and poor housing conditions, or even schools and other buildings, that we want to bring high quality construction to everybody and have the baseline of performance be quite a high baseline compared to how our typical buildings operate today. Preservation is another aspect that we need to work hand in hand with. Historic preservation, all ways of preservation that you may define it, and protecting our investments. Our buildings are huge investments, whether it's personally, as a family, as a business. There's a lot in real estate, and we want it to last and do the right job. And then certainly not least, if last on the list here, is comfort and joy. That our buildings need to make us comfortable. There's no reason to be suffering in our buildings in discomfort, whether it's in the winter or in the summer or otherwise. And so there are lots of individual strategies in dealing with these different issues. But one of the things we want to talk about is this idea of Passive House as a building methodology, as a set of principles, as an energy efficiency standard. And Passive House can be seen as a platform that kind of sets a baseline that supports all of these different goals. Next slide, please. So what is Passive House, right? You may ask. So it boils down to simply being a rigorous energy efficiency standard, the world's most rigorous energy efficiency standard. But at the same time, it's much more than that. And what it does and the quality of it that it brings to construction is that it functionally aligns efficiency with comfort and occupant health and many other benefits. And we'll sort of tease that out a little bit here. Typically, we think of efficiency as a sacrifice, right? That you're going to turn down the thermostat and be a little bit more uncomfortable or in one way or another. And what Passive House does through the methodology and the principles is actually say, you know what, actually the more efficient we are, the more comfortable we can be. And we can actually have more healthy interior environments. It's counterintuitive in a way, but it makes sense when you work your way through it. So we can sit at a window, right next to the window in the middle of winter and be comfortable. that glass is relatively warm. It's at the temperature of the surfaces around it. There's no radiator under that window. There are no mechanical systems blasting to make up for that. You have thermal comfort. Passive house, in approaching energy efficiency and this a functional alignment, is embedding the core performance in the enclosure of the building, in the architecture, if you will. It's really empowering the architecture in a way to be the lever that drives performance, not the mechanical systems as it traditionally is. We certainly need mechanical systems, but before we get there, we want to have predictable high performance. And this focus on the enclosure and its relationship to the environment and the occupants helps drive that performance in a way that allows us to radically reduce the mechanical systems, so they are not, as typically is the case, compensating for poor performance. In a passive house, they're supporting high performance. There's just a little bit that you need to bring it to maintain optimal conditions. Next slide, please. So that predictability is a huge deal, and that speaks to the optimization and really differentiates passive house from a wide range of green, sustainable building standards. We could talk about Energy Star or Net Zero Energy, LEED, Green Globes. There are many, many sort of building standards out there. But what we see is that, we'll take these graphs for a moment. What we see in the typical building code buildings, where there's no particular focus on efficiency and predictability, we have a wide range of outcomes. And consequently, we're oversizing mechanical systems. You might end up with an energy efficient building, but it might as well just be luck or the circumstances of a particular project. And the engineers are going to oversize the mechanical equipment just in case. They need to have major buffers to make sure that they don't get complaints after the building is occupied. A LEED and other sustainability goals are very admirable in all sorts of ways and will accomplish certain things and are important in certain ways, but ultimately they're not dialing in on the predictable performance. So you still can have a fair amount of variation. You still have a problem of optimization and the outcomes. Passive house will have variation. We're always going to have different occupant behavior. These are custom buildings, but we see that variation in a much more limited band, and that allows us to optimize. So very, very important in being able to predict the ultimate performance of the building. Next slide, please. So how we do that is really basic building science, as I said at the beginning, and being more intentional about it. Very often when I give a longer talk on this, and people will say, well, that's basic building science. Yes, that's true, but it's fully integrated and optimized, and you're really looking at how things allow you to leverage and make things more functionally better at the same time of cost optimization and formal design. So it's more complicated than 5 principles, but it really boils down to these initially. Climate-specific insulation levels, number 1, and it's continuous insulation. So there are no breaks. And think about it like, and climate-specific, so think about it like wearing a good parka on a winter day when it's cold out. We don't want to be going out in just a hoodie and a freezing day. We're going to be uncomfortable. And our typical buildings are essentially all wearing hoodies. And we're counting on our mechanical systems to make up for that poor dressing that we've done. So in addition to, so we typically have a bit more insulation, but it can vary. If you have a big building, the insulation levels could be de minimisly larger because of overall optimization. There are a lot of factors driving it. The key thing is thermal bridge-free insulation and thermal bridge-free connections. So part of that continuity, and think of it like a thermos. It's a very unsexy way to think of buildings, but a thermos is a good analogy for continuity of insulation. Typically in buildings where we have structural elements coming through balconies, window frames, the way they're installed, they are often thermal bridges where you have disproportionate energy flow through. So you have cold surfaces, you might have condensation if the humidity is a little bit out of whack or the temperature difference is too great. Thermal bridges can cause moisture damages, can cause health problems, and wide range of effects. So in a passive house, we are trying to eliminate thermal bridges completely, or we are minimizing them and calculating them and putting them into the energy model for the predictability. With continuity of insulation, we have also continuity of airtightness. And the basic idea here is to control the quality of something with any sense of predictability, you need control of the thing itself. And the way you have control of air is in an airtight environment. Once you have air under control, it takes very little energy to maintain high quality. And it eliminates drafts, it eliminates discomfort. And basically, if you take the same building with the same insulation levels and go from typical airtightness, which is not airtight, to passive house airtightness, you could have up to and more 5 times the heat loss. So you have completely different functioning building based on airtightness alone. And I think Christina will be pointing to some results around that. Along with the airtightness and insulation, then the windows and doors are part of that continuity. So oftentimes they're triple glazed, so we have good thermal protection, and they're triple gasketed for airtightness. A product of the airtightness as well and this enclosure is that the outside noise goes away. It's very quiet, peaceful in a passive house. So if you're in an urban environment or by a highway, noise, or even in the country where the bugs just make a racket, you can have that quiet and peaceful environment. We do have solar heat gains from windows and doors, and we do calculate them and use them, but these are not what you would think of as passive solar buildings. We try to keep that in balance, because if you overdo it with the solar heat gains, you can overheat unnecessarily the building and cause need for more energy on the air conditioning side than you would otherwise. So we have control of the building. We need to ventilate. Now, natural ventilation is a core strategy of passive house, and it seems counterintuitive, but if it's a nice day, you can open up the windows, let the air blow through. There's no problem with that. Overnight, cooling down during the summer, if you can do that, you can cool by purging the building with natural ventilation. And it is encouraged to naturally ventilate to the extent that you can. However, with passive house, we understand that you can't rely on natural ventilation all the time. You need to be able to ensure high quality indoor air, whatever the conditions are outside. So whether it's 20 degrees out or 100 degrees out, or if there are smoke conditions outside, you have outdoor pollution. You can't always have natural ventilation. Always isn't a good idea. And so we're providing ventilation like all buildings do, but rather than a intermittent bath fan or kitchen fan that's pulling air through the cracks in the building enclosure willy-nilly, we are with intention supplying fresh air 24/7 to the served spaces, the living rooms, bedrooms, offices, classrooms, and exhausting 24/7 from the service spaces, the bathrooms, kitchens, hallways, utility rooms, and such. And the trick here with the passive, so it's a fan, there's a fan running, and you need to do that. It's an active fan like all buildings, but the passive part is you have a heat exchange, and that air that's going out is going through a core that transfers the heat from the outgoing air to the incoming air. And it can have over 90% effective transmission. And we'll talk, I think, a little bit. There's different levels of efficiency, which can can affect the overall efficiency of the building, but you really can maintain a high level of quality just with these passive means. So this kind of sets the stage, and these elements really do not need to drive the design in an aesthetically determinative way. I would say it's more like thinking about it like gravity, that you need to deal with these building science issues, and then you find, working with it, the freedom of the design. Next slide, please. We're almost through this. So all those 5 principles and more, we're putting into an energy model. And so this is the tricky part. Like we were saying, we're calculating the thermal bridges, the solar heat gains, the heat losses in the ventilation system. And we're able to optimize the design in a way that we can smash the heating demand, which is absolutely critical in dealing with carbon emissions reductions and our overall energy use. And overall drive down energy use quite significantly, and end up with a different profile building, and do it in a predictable way. My one quick story here is, as an architect starting out my first Passive House project, I was able to do a townhouse retrofit in Brooklyn Heights. It was a pre-Civil War building, right? You wouldn't imagine it as a high-performance building. All the other houses down the street, these are 5-story, 5,500 square foot house, big house. All the other houses have 15 tons of air conditioning on them. We did the calculation, and we calculated 1.5 tons of air conditioning is what we needed, which is essentially a window unit that you would put in your living room in a typical building. And that's scary as hell, right? I mean, the clients are spending a couple of $1 million renovating their home, and we're saying, put in essentially a suitcase. So we doubled it to 3 tons, which seemed a bit absurd, but the house works beautifully, and it does work. And you need that predictability to be able to make that leap. Otherwise, you're going to say, no, well, we're going to put in 12 tons just to be safe. And the house won't work that way. Next slide, please. So we need to go to zero emissions. Renewables, net zero energy, we need to electrify everything. We need to stop burning fossil fuels, but we need to boil in the benefits of this transition. And Passive House is a really great way to do that. And as we reduce the energy loads, it gives us more flexibility in our power supply. You could do net zero in the building, you could do net zero in the community or the state, the region. We need clean energy. And we're going to have more flexibility the less energy that we use, and the more reliably that we can do that. Next slide. And so finally, we really should not be limited. We're just starting out. Passive House is just scratching the surface. We are encouraged by how it is growing. But even still, there are all kinds of examples, and there are tons of examples around the world. We have a factory here in Sri Lanka, which is actually a retrofit as well. There's a ton happening in China and everywhere. So we have affordable housing in Philadelphia, wood frame historic retrofit in Brooklyn, as well as a masonry retrofit, library, even an office tower, 800,000 square feet of office going up in Boston right now, just being finished. So that's the end of my part. I'm very happy to hand it over to Christina. I look forward to questions in the discussion after.
Thanks, Ken. Yeah, and there's some good questions coming in the Q&A, which we are saving for the end, and we'll make sure we have time to get through them, and including addressing existing buildings and existing building retrofits. So Ken said this already. Why are we talking about buildings? We spend all of our time inside of them, for one, and they contribute honestly over a third of greenhouse gas emissions in the Northeast, which is primarily where Wind's portfolio is based. So in order to mitigate climate change, we have to decarbonize buildings, both new and existing. I am focused mostly on new construction, but I'm happy to talk about existing buildings. And we've done passive house or near passive house level retrofits of existing buildings. So a little bit of sort of policy and finance the context or place setting to start. The way you get more green buildings and high performance buildings is through a combination of carrots and sticks and policies and incentives. Codes and financing and incentives go a very long way. Ken mentioned leveraging co-benefits of comfort and aesthetics and noise, durability, et cetera. That's all extremely important. But nothing goes sort of further in driving the development industry and the construction industry and the design industry towards developing and retrofitting high performance buildings than codes, local redevelopment plans, Princeton, energy codes at the state level, maybe more advanced federal carbon tax, things like that are what we're going to really need to see the age-old construction industry advance to the levels that we need to be advancing to. But we've come a really long way. I called out an acronym that is ingrained in my brain, which is LIHTC QAP. That stands for Low Income Housing Tax Credit Qualified Allocation Plan. This is sort of the state Bible for awarding low income housing tax credits, which is the equity or the financing tool that companies like WIN and companies that develop mixed income and affordable housing use to finance this type of work. And the qualified allocation plan is a tool that states can use to incentivize high performance buildings. And it's been really incredible. I started at WIN, it'll be 10 years in a couple of months. And 10 years ago, the QAPs didn't say much of anything about sustainability. And today they are essentially mandating for affordable housing that we build to passive house level performance standards, and that they're all electric, and that they incorporate battery storage and smart controls, and maybe they're grid interactive efficient buildings. The QAP is really why you see so many affordable housing communities adopting passive house. And you sort of look at the curve of new passive house buildings, at least across the United States, and they're predominantly affordable housing. It's sort of historically might have been sort of luxury housing and sort of higher end housing for a lot of the reasons why that Ken explained. You get a nicer product at the end, and it's the right thing to do. The QAP and the financing and the incentives that we often use to finance affordable housing projects has really allowed our industry to take off. And as a result, we're seeing more and more architects, more mechanical engineers, and more general contractors and developers alike learning building science, which is really wonderful. Next slide, please. So I promised the Sustainable Princeton folks that I'd touch on this. Obviously, the Inflation Reduction Act, maybe not obviously, but in my world, a $370 billion financing package to combat climate change is definitely front of mind. It's we've never really seen anything like this before, and it's really an incredible achievement for the federal government. And it'll be really exciting to see how the various federal agencies and state energy offices go about implementing and deploying these funds and these opportunities. I called out some just like sort of subsections of the IRA here on this slide. It's a 800-page document that references over 1,000 other documents and IRS code sections. But it's been really exciting to see how the IRA has really prioritized environmental justice, communities, and equity as they wrote this. And I think they got a lot of things right. We're really focused on a nearly $12 billion program from the Department of Energy's Loan Programs Office that's going to allow green banks across the country to finance energy retrofit work in existing buildings and new construction alike. as well as HUD's Green and Resilient Retrofit Program that is going to deliver $840 million to millions of HUD subsidized homes across the country. The EPA has unprecedented budget here of $27 billion to support clean energy investments. And what I think I'm even more excited about, even though the numbers are relatively smaller compared to Department of Energy and EPA, the state energy offices, every state has a shot at basically applying to the federal government for two new grant programs. There's the sort of homes rebate program and the high efficiency electric home rebate program that I've called out here. These are just grant opportunities that will be administered by states who develop a plan for administering them to support electrification and deep energy retrofits of existing buildings. So these programs are offering $8,000 to $14,000 per home for things like new heat pump systems, ventless dryers, building shell upgrades, even electrical service upgrades if you need to replace your electrical panel or increase the capacity into your building or into your home in order to accommodate the switch from a fossil fuel or fuel oil to electricity for heating or domestic hot water, for example. And then there's a few and sort of important tax credits and deductions that I've called out here that are worth researching further, and I can talk more about any and all of them. Section 45L is a new energy efficient home credit. This isn't a new credit, but it's none of these are new credits. They're sort of enhanced and expanded and extended. So the 45L credit used to only be available for buildings less than 3 stories. And it was sort of a fraction of the sort of value that it's at now, which is $500 to $5,000 per unit. And the value of this tax credit, it depends on the energy performance of the building or the unit or the home, as well as wage rates. So is it open shop or is it prevailing wage or union wages? Section 179D is not a tax credit. This is a tax deduction, and it offers pennies per square foot up to $5 per square foot, and that is tied to a % improvement over an ASHRAE baseline. So if you can prove that you're reducing the energy intensity of your building by 50%, you will qualify for a tax deduction worth $5 per square foot. That's a nice carrot to encourage retrofitting existing buildings. And then lastly, Section 48, this is the investment tax credit. The ITC has been around for many, many years. It's a tool in our toolbox that we've used to develop nearly 3 megawatts of solar PV across New England primarily. But it was set to expire in a couple of years. It had already declined from 30% to 26% and was going to 22% next year. It's been extended through 2032. And it's very involved, and there's many sort of do this or if this then that sort of criteria to navigate. But some of the highlights for us is that they included battery storage, standalone battery storage. It doesn't have to be paired with solar. They added ground source heat pumps or geothermal, which I don't have listed here, but that's a huge opportunity for electrifying. And they've offered, really importantly, 10 to 30% bonus tax credits for renewable clean energy projects implemented in low and moderate income communities, with the higher bonus tax credit available for projects that actually deliver the financial benefits of the renewable energy to low income families, i.e. share the savings, share the benefit with low income families. Next slide. So I want to jump into this case study. This is the Alice. This is a 125 unit new construction building that Wind Development is, has been working on very closely with Princeton, and we're very excited to be hopefully reaching a groundbreaking very soon, early in the new year. It includes 20% affordable units at the area median income or AMI levels bulleted out here. The project has focused on sort of, we don't want to, in our words, I think of it as something an architect in Boston, Michelle Lapighian at Icon Architecture says, stealth passive house. So we try not to sort of over label what we're doing. We're a little stealthy about it. We just design a really good building envelope. We electrify the systems. We've incorporated the principles of passive house without stamping the words passive house all over the plans and specifications. And that's strategic. It helps avoid the fear factor when you're dealing with general contractors that have never built passive house buildings before. And we have such a contractor for this project. We are pursuing a couple of, we'll call them traditional green building certification standards, which is Energy Star, multifamily new construction, and Zero Energy Ready Homes certifications. And I'm going to get into some of the strategies by which we will meet and far exceed the performance objectives of those programs, including the building envelope and the MEP systems. High level sort of project basics here. It is at the corner of the North Harrison redevelopment area at Terhune Road and South Harrison Streets, and will include EV charging stations, 133 kilowatt solar PV array, smart thermostats, and stormwater infrastructure. But the bulk of what I want to focus on again is the shell and the MEP systems. So next slide, please. Oh, but first some renderings. The architect here is PS&S, and I have to show that high performance buildings can be really sharp and contemporary and look really nice. Many of the apartments include balconies. I think that was a question in the Q&A. You can keep sort of clicking through the next 2 or 3 slides here. The project site has incorporated a lot of outdoor areas to congregate and meet, extensive landscaping and site work, including, again, as I mentioned, stormwater infrastructure, including fire retention and permeable pavements. Next slide. A dog park, green roofs, and the solar array on the roof, as I mentioned, along with the roof deck here, which we're really excited about. We have 15 spaces that will have electric vehicle charging stations on day 1, and another 10 spaces basically with conduit and dedicated circuit breakers for future electrification of those spaces. So we'll basically be prepared to meet demand as it comes. Next slide. So the building envelope is the most critical component, right? Ken talked a lot about the sort of 5 principles of passive house, and they're drawn right here, many of them. So the building includes 3 inches or R12 continuous insulation outboard of the sheathing. This is truly continuous insulation. Continuous insulation is not broken up by metal thermal bridges every 16 inches. So our project includes what's shown here is a thermally broken rain screen system, so that the continuous insulation is exactly that. It is continuous. That's really important because the cavity insulation, while maximized here, we have 2x6 wood studs that will be dense packed with R23 spray applied cellulose. The continuous insulation is really critical for getting that very robust thermal performance of your exterior wall. All of the glazing is triple glazed. So we have triple glazed windows. All the balcony doors are also triple glazed. We're using Passive House certified products for that. We've been working really closely with the window manufacturers as well to make sure that the air sealing details at all of the window openings and balcony details are comprehensive, not only for water management, but air infiltration as well. We talked a little bit about air infiltration. I've highlighted various details here. This is straight from the permit set submitted to DCA. So the building envelope includes a liquid applied air vapor barrier, but also air sealing details at all of the exterior studs and demising walls. So we're talking about compartmentalization of apartments, making sure that we don't have air and odors and sound transferring from apartment to apartment and apartment to corridor. but also apartment to exterior. And we'll be testing and inspecting that throughout the construction. So we'll be testing it at the apartment level, again, sort of compartmentalization. How is each apartment performing? But we'll also do a whole building blower door test, which is a passive house requirement, targeting 1 ACH 50 for the entire building envelope. And further addressing thermal bridging. I mentioned the thermally broken clips, but also using spray foam at the rim joists. And we've gone through very rigorous design reviews with our sustainability consultant, it was McGrath Associates, basically with a red and a blue pen, sort of old fashioned, but we look at the building elevations, we look at the floor plans, and we trace everything. We make sure that where there's an air barrier, there's a thermal barrier, and that everything is continuous around the whole building envelope, as well as within the sort of cube of each apartment. Next slide. So with this robust building envelope, we were able to, comfortably, responsibly electrify the heating system. I have to admit, this wasn't the first iteration of the building. The building started out as, as many buildings do, a sketch from our architect with very little sort of specific direction from us yet. And it included a gas boiler in every single apartment, sort of a traditional way of heating and providing hot water. And double glazed windows, sort of typical Energy Code, Energy Star building. Before we said, no, this is how we intend on building this building, working with Princeton to enhance the building envelope, to include the details in the assembly makeup that I just described, and drastically downsize our HVAC systems and comfortably electrify the heating system from the tankless gas combi boilers to the high performance cold climate certified air source heat pump systems that are shown here. We were able to reduce them by 30%, the total tonnage on the cooling side by 30% when we made the switch from double glazed windows to triple glazed windows, which is incredible. So a slight cost premium on the windows and glazing package, but a large savings on mechanical equipment, the size of the ductwork, and it'll have long-term operating expense or operating savings for the residents who will be paying for their own electricity. Ken touched on energy recovery ventilation. The building has a central ERV system, which is constantly pulling stale and moist air from kitchens and bathrooms, supplying fresh air that has been preheated or cooled with the exhausted waste air to all living spaces throughout the building. So common areas as well as apartments, and a fully balanced system. So every CFM of air that's removed from the building is replaced with an equal amount of CFM to the building. Each apartment does have in-unit laundry. I fought that one, but lost. And we'll include ventless dryers, again, to help preserve the continuity of our exterior envelope. And then these are kind of normal commonplace features at this point, but 100% LED lighting, all of the common area lighting on occupancy controls, and smart thermostats in each apartment that will allow residents to hopefully really control the way that they choose to use energy day to day. Next slide. I mentioned this before. Here's just a kind of a roof plan that shows 133 kW solar array up on the roof. We're really maximizing as much space as we can while avoiding shading from the mechanical equipment. One downside of sort of individual air source heat pumps is that you have a condenser for every apartment up there. Luckily, when we made the switch from the traditional condensing unit and air handling unit that was tied into that boiler plant, we got these really sleek, sort of slimmer outdoor units, and actually we're able to increase the size of our solar array as a result. And New Jersey has a very, not compared to DC and somewhat with Massachusetts, but New Jersey has a great solar program with a 15-year SREC valued at $100 per rec, which is great. And the investment tax credit that I mentioned earlier means that the cost of the solar will be offset with a 30% tax credit on day one, which is fantastic. Next slide, please. So I'm trying to wrap up by 8, and I think hopefully we'll be able to go over to take some Q&A. takeaways here, building small, large, institutional, multifamily that can be designed and built to near net zero performance. I didn't touch on this, but decarbonization and electrification are not words that I used pre-pandemic. That has nothing to do with it, but 3 years ago or more, we weren't using those terms. We were talking a lot about energy efficiency, electricity use, natural gas use, fossil fuel use. Now we talk about carbon, and I think it's a smarter, more sophisticated way to consider how our buildings are using energy, and it's helping us to electrify more responsibly. And I think we're doing that thanks to passive house design principles that offer a building science focused methodology and framework for achieving low energy, low carbon buildings. Yeah, and I'll end on the importance of the sort of carrots and sticks have a role. Obviously, I think we take a lot of pride as a long-term owner, knowing that we're delivering high performance communities that we're very proud of. But community redevelopment plans and strong codes and building performance standards at the local and state levels certainly have a role to play as well. So with that, I think we're finished with our presentation and look forward to the discussion.
Well, thank you so much. I think I'm back in action now with my main camera, so hopefully the Q&A will go a little bit more smoothly than the introduction. We have a lot of questions, so I know we thought we might be able to cover this in an hour, but clearly we're not going to be able to. So if you've got the time, we'd love to go through these questions. I see a number have to do with insulation, so I'm going to group these all together. There's a question here about from Linda Mead, who is executive director of DNR Greenway, a great nonprofit in our town. She's asking about, are you familiar with tap insulation, which is marketed as green, environmental friendly, and pest control blown insulation, and do you recommend it? And Tammy Sands, who's the chair of our environmental commission, has a follow-on question about, she's asking the same for hemp insulation.
I personally have not used either. I just Googled tap insulation. So I don't know if Ken did as well. I mean, what I'll say to that is we're seeing more and more low carbon, embodied carbon options available to us, hemp insulation being one of them. I think there's some really exciting products coming that Ken can talk more about for wood fiber insulation, to really get away from foam and plastic-based insulation material. We're obviously using cellulose, which is a relatively low embodied carbon material as it is, and mineral wool on the exterior instead of polyiso foam. That was an embodied carbon driven decision. Neither of those are tap or hemp based products though. So I don't know, Ken, do you have anything to say about those products?
Well, yeah, I was just reading a little bit while you were presenting, Christina. And so the tap, I'm not familiar with it, but just from reading on their webpage that it's a cellulose insulation. And cellulose typically comes with borates added to it, which is used for, helps with the insects. It's also a fire retardant. And so it looks to me like I would describe it as a branded version of cellulose insulation. And so there are lots of cellulose providers. It's a great insulation in terms of, as Christina was saying, low embodied carbon, because you're using recycled product, you are carbon storing in the building. So definitely a lot to recommend it on the face of it. Hemp, similarly, you're using rapidly renewable product. I think with any insulation, and without getting foam insulation can be problematic because of the toxicity issues, because of its long-term performance issues. We do see people trying to minimize it. With any of them, it's really a matter of the R value, the insulation value of it, and then the embodied carbon, how much energy is going into making it, which we try to minimize.
Right. And there's another question here from Mark Berhaney about commenting on the pros and cons of open cell foam insulation versus closed cell foam insulation.
We've used both, and they have their sort of correct applications and incorrect applications. We're usually using closed cells spray foam because we don't want water and moisture to move through it. If we're in a basement, we might choose otherwise. We usually have the thought or mind leader tell us which one's better and might require a hygrothermal analysis to do so. We get a higher R value per inch with closed cell. Yeah. Can anything beyond the basics there?
Yeah, I don't think that, I mean, definitely, you know, it typically has a higher embodied energy value to it, and there could be off-gassing issues with it and whatnot. It can be used
with closed cell, Ken?
With closed cell, yeah, sure. Which there are ways to mitigate that and deal with it. So each has its place, and each can be used responsibly. Jeremy Avellino might take exception to what I'm saying, but but I do think there's no hard and fast rule to it. We could, but in any case, you should be looking closely at the moisture properties and doing hydrothermic models to evaluate that.
One, I'll expand a little bit just because it comes back to the sort of retrofits. We do a lot of historic adaptive reuse work in old mill buildings and old school buildings that we convert to loft apartments, low-income multifamily space, and historic National Park Service and state historic preservation offices limit how much we're allowed to do with those walls. Obviously, we can't do anything from the outside. These are beautiful, you know, brick, ornate, or granite block buildings. So from the outside, they have to continue to look that way. On the inside, we're only allowed to fur out and insulate a portion of those walls, and we're only allowed to fur out 4 inches, no more than 4 inches. So if you use 5/8 of that 4-inch allowance for your drywall, so you sort of have 3.5 inches to play with. And we are using closed cell spray foam where we can, as long as it is not sort of creating a new freeze thaw issue with the masonry, but we're using closed cell spray foam to maximize the R value that we have within that very limited space. So I do think that closed cell spray foam has a space in historic adaptive reuse, high performance historic adaptive reuse spaces, more so than new construction.
Okay. Thanks. So we have an architect in town here. Tom Pino is asking if there are any certified passive house projects in Princeton outside of the university. And if either of you don't know the answer to that question, maybe someone in our audience does and can put that in the chat. I'm not aware of any.
There's one database that I looked up right at the beginning of the presentation, and Princeton's dorm was the only one that showed up there. But that was just one database. So I'm sure there's more.
And is there, you talked a little bit just now, Christina, about renovating or retrofitting existing structures, commercial and residential, to meet passive house standards. Is that easy to do? What are sort of the things that you look at, or what is you need to consider to retrofit existing structures?
It's definitely not easy to do, but it's really fun. And it's super important, right? So I think 2/3 of the buildings that exist today will still exist in 2050. So if we're really talking about decarbonizing buildings, new construction starts is important and much easier, but it's not going to get us all the way there. So we are doing an existing occupied building, deep energy retrofit that will achieve EUI in the mid-20s or passive house level performance. We're doing that by installing continuous insulation to the existing facade and electrifying all those systems and installing ERV ventilation systems because we're tightening up the building so much. So in an existing non-historic building where we can basically reclad the exterior and tie that back into the existing structure, assuming that structurally it can support the weight of new exterior insulation. That's that's one strategy. It's extremely expensive, but I think that's the future of energy retrofits of existing buildings. And I think that that's appropriate in cold climates and in, you know, buildings sort of pre-war that don't have any insulation in the cavities and might not have an exterior wall stud cavity to insulate in the first place. And then, but on the historic adaptive reuse front, as I mentioned, we're sort of limited within the historic tax credit space. One way that we're doing that is, you know, trying to maximize insulated wall area and specify thermally broken windows, but it's much more difficult in historic applications. Ken, you've worked on existing building passive house.
Yeah, I was going to say, so kind of counterintuitively, passive house really grew the most rapidly initially in New York, in Brooklyn, in Brownstone, Brooklyn. And so we're dealing with 100-year-old houses across the board and different structures as well, historic masonry retrofits. And, you know, there was a lot of concern initially, and certainly a lot of initial pushback from the historic preservation groups in terms of what we were doing to the buildings. And it was actually a good process ultimately in terms of having a conversation about building performance, about what we could do with these buildings, how the buildings could actively contribute to the climate solutions that we need. And that, you know, ultimately from our position and from experience, like we know so much more now than we did 12 years ago. And there's just a lot of experience in it. That, you know, it's not good enough to just say it's an existing building. And so it's sustainable. We can actually have them be at passive house performance and truly decarbonize and have a big like pinwheel, you know, multiplier effect in its in what it can do. And having the preservationists like actually applaud it and see it, which is very gratifying at the end of the day.
So got a couple of questions here that have to do with you know, the air quality and the perception about a passive house being unhealthy. You know, we have a question about, do windows open in passive house construction? What about amenities such as balconies? I think the answer to that is yes, correct?
Yeah, I mean, you know, at a cost, right? So the more windows you have, the more balconies you have, the more thermal bridges you're mitigating and dealing with, and the, you know, the higher performance windows you're buying to offset the loss of opaque wall. But absolutely, you know, as long as you can hit the sort of allowable heating demand and overall EOI goals, then you're good to go.
Yeah. The only thing I would add to it, it's kind of counterintuitive, is people see it as a limitation, like you're in a passive house, so you can't open the windows. I would flip that logic on its head and say, you don't need to open the windows. You can open the windows if you want to, if it's a nice day and the breeze is blowing, and by all means go for it. But the indoor air quality is good. It's probably better inside than it is outside. So you're not feeling stuffy. You're not feeling like you're being overwhelmed with VOCs. And so you have a good quality. And so it's actually empowering you with more choices, not taking choices away.
And could you explain a little bit about the air exchange, you know, to the question we have here, that they've understood it to be unhealthy for a building to be too airtight. And if that's not true, or if it is, how do you deal with it?
Do you want me to jump in, Christina? Or?
Sure. Yeah. I keep answering first on that.
So, no, please. But I'll say, it's a misnomer. We call it a case of mistaken identity. Certainly, pre ventilation systems and whatnot, you needed to purposefully have natural ventilation, but it was more of an accident of just poor construction. People weren't trying to make airtightness. Certainly in the more severe climates, you'd make something more airtight. If you were building in Alaska, You would make something more airtight than you might otherwise, right? What you need is not airflow through the enclosure. What you need is the moisture to be able to move through it. You need the enclosure to be able to dry out. And so that's why when we're talking about closed cell foam or different materials in the enclosure that have that become barriers to moisture movement and moisture drying out, you need to carefully look at those enclosures and make sure that you're building safe enclosures. So vapor, open, breathing, typically good, and air tightness on the other side, good. So.
Thank you. I see a question here from Jeremy Avellino. Can you briefly explain the certification process for non-residential retrofits to the Passive House Building Standard?
Jeremy could answer this question. I don't know. I read that. I'm curious to what you're getting at, Jeremy. Because they're pretty much the difference between commercial and residential isn't, or there isn't a difference per se in certifying to retrofit, to renovations. It's more the difference between retrofitting and new construction. So between retrofitting and new construction, you have a slight relaxation and you have exceptions, and there's more leeway dealing with the retrofits because you have conditions you can't necessarily mitigate completely, and you have regulations. And like Christina was saying, with some of the constraints that they have. But in terms of commercial versus residential, you pretty much need to go through the same set of processes and calculations. The big thing is you can do in retrofits, there are a couple of ways. You can either do it as a gut renovation, which, you know, to hit passive house levels, you really need to do a full renovation in one form or another, or near gut. Or you can do it step by step. So as you need to replace systems, as you're replacing windows, as you're doing different aspects of the building, you make a long-term plan to do a retrofit. And I would say the key thing conceptually different between passive house and traditional approach is that when you're replacing a window in a traditional building, you are just you're saying, well, the walls aren't that great, so I'm not going to put in that great of a window because it doesn't make any sense because the wall isn't that great. In a passive house retrofit, you're saying, no, I'm going to put in the best window that we possibly can, knowing that down the road, we're going to improve the enclosure and bring it up to that level so that once you've gone through the whole building, you have passive house performance.
That sort of, we call it the zero over time methodology is really helpful as we think about basically incorporating decarbonization into asset management. So if we know that a boiler is 20 years old and has a 30-year useful lifespan, we're planning for the electrification of that system in 10 years, and we're budgeting for it and sort of predicting that. And we can align these retrofit measures and upgrades with the building needs. And you see this in sort of Boston or New York City Local Law 97, and Boston it's BERDO standard, and DC BEPS, a whole bunch of acronyms. But they're ratcheting down existing building sort of carbon caps every 5 years between 2025 and 2050. They're not just going straight from 2025, from today to zero. They're giving us an opportunity to incorporate these changes in phases, which is helpful for planning and financing the retrofits.
Yeah. A question from Mary Joan: will any of these practices be used in our current and upcoming housing redevelopment projects in Princeton? So the case study, the Alice, is one that's part of the redevelopment projects in Princeton. I am not aware of any others. It doesn't mean they aren't going to be. I think some are still in early stages, or I don't know if anyone in our audience has an answer to that and could put that in the Q&A, and we'll answer that.
I think Jeremy's doing one.
Jeremy's doing one? Jeremy Avellino?
He can confirm that.
All right.
Jeremy's a great architect out of Philadelphia.
We hope they all do this. Okay, this is a question from Anne-Marie Lyles. How far would we fall short if we completely stopped building new building and focused only on retrofitting old buildings? It seems to work in Barcelona, the epicenter of creative architecture. It would also prevent further loss of biodiversity by building on land that could be restored for biodiversity.
I think it could have a tremendous impact on carbon emission reductions and improving the health and comfort in those buildings. I don't think that it's going to address the other crisis at hand, which is our housing shortage, right? So I think we need to be doing both. But as I alluded to earlier, I think we can have a greater and higher impact by retrofitting existing buildings to passive house, low energy standard than we will be able to do by building new buildings alone and vacating existing buildings. But we sort of think of everything that we're doing as tackling two crises at once: a housing crisis and a climate crisis.
Yeah. And I think with the Alice project, you're building at some place, an area that's already redeveloped or been developed. So you have all the existing infrastructure, so you're not needing to build that in a place that has never been developed and altering limiting the biodiversity of those undisturbed places.
Yeah. And I would just add, adaptive reuse first and foremost, that if we can avoid tearing down buildings, that's the best, and reusing the structures, we may be adding on to them. I mean, we're typically going to be increasing density. That's the thing. We need to increase density on the existing footprints of where it's disturbed and urban. And what we see in European cities is where they're building a lot of new buildings there in Barcelona and the other historic cities, but they're building in high density in very, careful infill in new districts. So
density saves nature, right?
Yeah.
Speaking of European cities and countries, in Germany, I believe some houses have no heating systems because of their insulation. Is this true?
They have heating systems. They're typically very small heating systems. I mean, the joke is basically if you build a passive house, you can heat your house with candles. You're basically heating your house by cooking, by taking a shower, your dogs. That's the vast majority of the heat load that you need. And you just do a little bit. It's not uncommon for affordable project to just have the worst efficiency heater possible, is just a baseboard resistance electric heater, because they require so little heat and you can still hit the numbers. So there may be houses without them, but that's not the standard methodology.
Right. Let's see, what reference for specific grants focused on nonprofits who retrofit their buildings to become more energy efficient? I think some of the things you listed on the slide with Christina, with the acronyms and a lot of sections, there might be some in there. We're trying to understand a little bit more with the Inflation Reduction Act, but it's our understanding that one of the benefits of the legislation is something called direct pay or transferability, which allows nonprofits or local governments to be able to directly access or benefit from the investment tax credits or rebates and incentives rather than having a third party take that. So I don't know if you've been hearing how that's going to play out, but it seems like that's a big deal for nonprofits and local governments.
It's a huge deal. Yeah, I mean, you basically get cash. I think the timing at which it comes in is up for debate. The Treasury Department is currently taking public comments and defining that. If you have to wait for that tax credit check to come in after the project is placed in service, does the nonprofit have to bridge that source with a loan, or how is it? How are you paying the bills the year before that payment comes in? Those are the questions that I'm seeing and hearing from a couple of the sort of groups that are working with the Treasury right now. I don't have an answer for that, but that is a fantastic opportunity. And I mean, I would encourage nonprofits to be looking at the state energy office programs and making sure that your state energy offices are developing programs. The Fed's not just giving the money out. You have to put together a proposal and ask for the money and prove how you're going to spend the money in a way that is consistent with the objectives of those two programs. And if you can't spend the money, or if you don't have an adequate plan, they're either not going to give you the money, or they're going to take the money back and give it to a state that can, right? So I'd encourage everybody to make sure that that New Jersey's developing a plan that's actually going to qualify for the money and get the money out the door.
Yeah.
We should also give sorry, Christine, we should give some credit to New Jersey Clean Energy Center and New Jersey Clean Energy Program. The ALICE will qualify for nearly $2,000 per unit for the energy saving. So they sort of give you I think it's $1,500 a unit if you're zero energy ready homes, plus a certain dollar amount per MMBTU of energy saved beyond that threshold. And so we're quite far beyond that threshold, and that's a great resource available to basically any ratepayer in the state.
Yeah, we certainly encourage and hope that all developers take advantage of the state incentives. And I'm pretty confident that our Board of Public Utilities is going to make sure that they have a plan in order to receive the federal funds. But we'll be tracking the incentives and the direct pay and transferability for nonprofits here, and help make sure we get the word out to nonprofits in our town. A couple questions that have to do with, the fact rental properties and multifamily. For a rental apartment building, how is energy generated by the solar panels allocated? Is it offsetting energy use of shared spaces, or is there a way to allocate energy to residential units? And then there's a question about master metering versus individual metering, as a way to see if I lost that question here.
I see it here, to help them learn how to decrease their carbon footprints. So our project is not master metered, it's individually metered. So every apartment will have its own electric meter, and we'll have a house or common area meter that picks up all of the common area loads, which is the ventilation system, pumping energy, common area lighting, heating and cooling, the 15 EV charging stations in the parking lot, all the site lighting, relatively large load. And the solar is going to offset a portion of that only. There are community solar programs available, and including in New Jersey, where you can develop solar and assign, basically net meter the power to designated accounts. So you're not, I'm not building 125 tiny little solar arrays and interconnecting each solar to each individual electrical panel. You can do this sort of virtually in Massachusetts. Virtual net metering credits in DC, their community renewable energy facilities, or CREFs. It's all community solar. And I think community solar is going to explode in the next year, because it basically qualifies for another 10 to 20% ITC. So you might qualify for up to 50 or 60% ITC if you can deliver the financial benefits of community solar projects to LMI households. Depends on the utility companies and the program and infrastructure available to you. But again, we could choose to allocate the power from the solar to residents who want to sign up for that. It gets a little messy. You're not only the landlord, you kind of become the electric company also, assuming we wouldn't be giving it away for free, although we are doing that in DC. So there's an option there. And we're not master metering and then sub-metering for a couple of reasons. New Jersey Housing Finance Agency doesn't allow it. That's not applicable at the ALICE because it's not a LIHTC deal. but most of the projects that we're doing are low-income housing tax credit projects, and NJHMFA prohibits master metering. And then in most states that at least we operate in, you are not allowed to sub-meter and bill back, and it's heavily regulated by the Board of Public Utilities or Department of Public Utilities in Massachusetts. It becomes difficult to regulate how you might be passing costs on to residents. It's further complicated if you're heating your building with electricity. You're not allowed to sub-meter and bill back for heat in any low-income multifamily housing. So it's mostly a policy and regulatory prohibition on master metering. I'd also just say I think we've seen this proven time and time again when residents and households pay for their own utility bill. They care more about how they're using energy, and they're more cognizant of that and make more conservative decisions around that if they're getting their own bill.
Yeah, great. I've got two more questions here, and we'll take note of the questions that we weren't able to get to, and perhaps we can follow up afterwards and respond to them via email. In the passive house design strategy, how are trees and gardens included in the plans for energy use and stormwater management?
I'll say the trees. So the landscaping is in the energy calculation for the building insofar as they're affecting the solar shading or the solar gains. So the landscaping can be a wonderful way of naturally protecting from overheating and allowing for solar gains in the winter with deciduous trees. Just good old fashioned, it's not just basic building science, it's like vernacular architecture, right? Vernacular landscaping. But there isn't per se water usage or landscaping aspect to it. Is really focused on the conditioned envelope of the building.
And do you keep a list of professional certified design and build or retrofit to passive house standard? Or can
professionals, yeah. So yeah. You could go on our website, passivehousenetwork.org. You can go to passivehouse.com, and there's also fias.org. So all three websites have pathways into finding people working in passive house.
Great. Well, we are at 8:31, and sorry we weren't able to get to all the questions. My colleague Alana is going to put a link in the chat to some resources and information about affordable housing in Princeton, about the past and the future. You might find those references interesting. I want to say a huge thanks to Christina and Ken, and also to the folks at the New Jersey chapter of the AIA, particular David von Stappenbeck and Lorianne Jones to help organizing this. Thanks to our team for helping pull this together. And thanks to all our audience members who stuck it out to 8:30. A reminder, you can find a recording on our YouTube channel, and the slides will be available on our website for folks to look at later. Any parting words, Christina or Ken? What would you, what are you kind of hopeful for the future when it comes to sustainable building and sustainable design?
I'm hopeful for more. I mean, you're gonna think I'm pandering here, but I'm hopeful for more communities and community involvement like Princeton. We develop all over the Mid-Atlantic and Northeast, and sometimes I wish that we had city council members and planning boards and economic development folks that asked us harder questions. And I think I've been very impressed and encouraged by Princeton's leadership, and excited to see that transfer to other towns and cities across the state, because there's a lot of power there. So hopeful about that and very excited about our growing sort of workforce and industry expertise for developing high performance buildings.
Yeah, and I would just add, I'm hopeful that, you know, we get caught in the sort of technocratic speak and all the details and science and all of that, but it's really about culture change, and it's really about changing the conversations and changing the expectations and how we're dealing with it. And I think, as Christina's saying, at the community level, in industry, the manufacturers, the builders, the architects and engineers, there's more engagement. And as more people are coming into the conversation, it's just much more lively, diverse, and we'll be able to just go so much further faster. We're just getting started, you know, it's like day one, unfortunately, but it's growing.
Yeah, well, thank you very much. And I wish everyone a good evening, and here's to a more sustainable Princeton, and everyone have a good night.
Thank you.
Thanks all.
Sure. Bye.
Bye.